Let's say you run a massive industrial facility. Every month, your process creates thousands of gallons of trade effluent. It's toxic. It's highly corrosive. Disposing of this legally through certified waste management costs you $50,000 a month. That cuts deep into your profit margins. Or you have a second option. You wait until 2 a.m. You find a heavy iron manhole cover on a deserted road. You pry it open, attach a hose, and let the toxic effluent flow straight into the municipal grid. You just made your expensive chemical problem disappear for free. But what you don't realize is that you just triggered a silent alarm. Deep inside the network, a VOC unit just caught your unique chemical fingerprint. An anomaly just spiked on a dashboard, and the wastewater detectives are already hunting you down. When you run your sink, you assume the city just magically handles the water, but beneath the asphalt lies a massive, invisible vascular system. Think of the city as a living, breathing organism. The concrete sewer pipes are the veins. Gravity and high-pressure pump stations force millions of gallons of liquid through this grid. It all flows toward a single destination, the water reclamation plant. This massive facility acts as the kidneys of the city. A modern plant can process over 200 million gallons of wastewater every single day. It filters and purifies the water so it can be safely returned to the environment. But this sprawling network wasn't just built for household toilets and showers. It carries something much darker. It carries trade effluent. Trade effluent is the liquid waste generated by commercial and industrial businesses. Factories, chemical plants, and manufacturing hubs generate massive volumes of it. Creating the products you buy every day requires water, and that water gets contaminated with industrial byproducts. We are talking about heavy metals, solvents, and volatile organic compounds. It is a heavily regulated chemical cocktail. By law, factories must pre-treat this effluent. They have to neutralize the chemical load before it ever hits the public sewer. They do this so the city's kidneys can safely digest the waste. But pre-treating industrial waste requires expensive equipment, and hiring certified chemical disposal trucks costs a fortune. So some factory owners look for a loophole. They bypass the regulations entirely. They dump raw, untreated trade effluent directly into the public sewer. And when they do, they unleash a very literal chemical war underground. Money is the root of this underground war. Running a legitimate factory is incredibly expensive. Manufacturing electronics, electroplating, or processing food generates massive chemical runoff. We're talking about volatile organic compounds, industrial solvents, and heavy grease. If you play by the rules, you have to build an on-site WWTP. You have to pay licensed contractors to haul away the most toxic sludge. Hazardous waste disposal can easily cost $300 per cubic meter. If your plant generates 100 cubic meters a month, that is $30,000 every single month. It is a massive operational tax on your business. But human greed is a powerful force. Some factory owners look at that bill and see a different path. They realize that gravity is completely free. So they bypass their expensive pre-treatment filters. They install hidden bypass pipes, or they literally load up tanker trucks in the dead of night. They drive to an isolated industrial park, pop open a sewer grate, and pull the lever. This practice is called midnight dumping. It instantly transfers the cost of doing business from the factory to the taxpayer. It is a highly profitable, invisible crime. But dumping this raw, untreated chemical cocktail doesn't just cheat the system, it physically destroys it. Because trade effluent doesn't just flow through the pipes quietly, it eats the network alive. The municipal grid is built to handle human waste, not industrial warfare. When factories dump untreated trade effluent, they attack the network from all sides. It is a holistic threat to the entire infrastructure. Let's start with the physical pipes. Highly corrosive waste doesn't just flow harmlessly to the plant. It reacts with the biological slime inside the sewer. This reaction produces hydrogen sulfide gas. That gas aggressively eats away at the concrete walls of the pipe. It exposes the steel rebar, rusting it until the pipe eventually collapses. But acid isn't the only weapon in this underground war. Food processing plants often dump massive amounts of heavy fats and oils. In the cold, dark underground, this hot grease congeals and hardens. It binds with flushed debris to form massive rock-solid fatbergs. These blockages choke the pipes and back up the entire system. Then you have the volatile organic compounds, or VOCs. Chemical plants dumping solvents turn the sewer into a ticking time bomb. These toxic fumes build up inside enclosed manholes and pump stations. A single spark can trigger a massive underground explosion. The physical damage to the network alone costs millions to repair, but the pipes are merely the delivery system. The real catastrophe happens when this toxic cocktail reaches the end of the line. It is heading straight for the water reclamation plant. The water reclamation plant is the city's last line of defense. It is an engineering marvel, processing millions of gallons of sewage daily. But the heart of this massive facility isn't a machine. It is a living, breathing biological engine. Inside the aeration tanks, trillions of microscopic bacteria are hard at work. This is called the activated sludge process. These hungry microorganisms literally eat the raw sewage. They consume the organic matter and purify the water naturally. It is a delicate, finely tuned ecosystem, and it is highly sensitive to extreme chemical changes. When a factory dumps a massive slug of toxic trade effluent, disaster strikes. Imagine injecting a lethal dose of chemotherapy directly into a healthy kidney. That is what heavy metals and industrial solvents do to the plant. Sudden spike of toxic water hits the bioreactors. The shock wave instantly massacres the microscopic bacteria. The biological engine simply flatlines. Without these microorganisms, the plant is completely useless. It cannot filter the raw sewage. Millions of gallons of contaminated water threaten to bypass the system. Restarting a dead biological reactor is an absolute nightmare. It can take weeks and cost taxpayers millions to reseed the bacteria. By the time the plant operators realize the engine is dead, it is too late. The toxic water has already flowed through. This is the fatal flaw of a reactive system. To stop the midnight dumpers, the city needed to evolve. They needed to catch the poison before it ever reached the plant. The old way of fighting this underground war was completely broken. It was a hopeless game of reactive whack-a-mole. If the water reclamation plant was the first to realize something was wrong, the battle was already lost. The alarms would sound, and the city would deploy their investigation teams. These wastewater detectives are known simply as the hunters. But navigating hundreds of miles of subterranean concrete takes time. By the time the hunters finally traced the anomaly back to the suspected source, the pipes were dry. The toxic effluent had already washed away. Sometimes, if the hunters get lucky, they can still trap them. The culprits think they are absolute geniuses. They meticulously plan their dumping schedules to fool the investigators. But relying on a lucky catch isn't a sustainable strategy. The hunters realized that guarding the end of the line was a fatal mistake. They needed an effective way to work around this blind spot. They had to catch the dumpers in the act. So the hunters are currently building a proactive defense grid. They are turning the city's veins into a massive, smart nervous system. Engineers are physically dropping hardware down into the dark manholes. They are installing highly sensitive VOC sensors to sniff out volatile organic gases. They are deploying advanced ME systems to continuously monitor the chemical flow. These nodes sit silently in the network, guarding the heavy industrial zones. If an electroplating factory opens a bypass valve at 2 a.m., the grid feels it. The water chemistry instantly changes. The sensors immediately capture the illegal discharge in real time. But recording the crime isn't enough to stop the dumpers. That raw data has to be weaponized, and it has to happen with ruthless speed. All those underground sensors don't just record data into a void. They're hardwired directly into a centralized command dashboard. Think of it like an air traffic control center, but for sewage. The hunters are watching these screens, tracking the flow every single second. Smart management systems aggregate all this factory data and schedule logic. Suddenly, a massive VOC anomaly flashes red on the monitor. In the past, Inspectors relied on scheduled, time-based factory visits. But that was just relying on blind luck. Now the entire operation is event-based. The dashboard instantly pinpoints the exact catchment area of the discharge. It narrows down the search from hundreds of miles to a specific industrial zone. The moment that alarm hits, the hunters are activated. They deploy immediately to perform rapid source tracing. They pull physical samples from branching manholes moving upstream. They follow the chemical fingerprint backward, narrowing the path at every pipe junction. They track the toxic flow right up to the source, until they are standing directly over a single factory's discharge pipe. The trap finally snaps shut. The midnight dumper is caught red-handed before the plant ever fails. But catching them is only half the battle. Now it is time to make them pay. When the hunters finally corner a midnight dumper, the penalties are brutal. We're talking about multi-million-dollar fines and criminal charges. But these massive fines are not just arbitrary numbers meant to punish. They are a highly calculated bill. They represent the exact cost of replacing miles of destroyed sewer lines. They cover the millions of taxpayer dollars spent reseeding a dead biological engine. For decades, some industrial factories treated the subterranean grid like a free garbage dump. They pushed the true costs of their manufacturing onto the public. But the era of blind, reactive wastewater management is coming to an end. The grid is getting smarter. The underground veins are actively being wired with sensors, and the dashboards are being watched 24 hours a day. So the next time a factory owner thinks about lifting a manhole cover in the dark, they should remember one thing: the wastewater hunters are already waiting.